Okay, ladies and gentlemen, we need to talk about functions and transformations. Now, we've been talking about functions, what is a function, how we can work with functions, in behavior, different attributes of functions. Now we're going to talk about the functions themselves. On page 45, so if you go to page 45 of your book, or included with this information, you have the graphs for the various parent functions. Now, a parent function is simply the basic function for which other functions are built off of. So the functions come from right here. Now, what I've done here is I've taken those graphs and I've simply colored them in a little bit more nicely so that you can see them. You'll notice our basic families of functions are, you have the constant function, meaning it moves constantly across from left to right. In this case, the key thing here is it's linear, but its slope is 0. Here you have the f equals x function, f of x equals x function, which is nothing more than a straight line at a 45-degree angle. You have the traditional square that we've used so often, a cube, a square root. Then you have the rational or reciprocal function, which is 1 over x. And you'll notice it creates these two pieces because it's undefined at 0. It also is going to have a horizontal asymptote at 0 this way. So there's 6. Now on top of that you have the absolute value function, and it comes down until it reaches 0 and it bounces back up. So that's your absolute value function. Finally, you have the step function or greatest integer function. Those are your 1, 2, 3, 4, 5, 6, 7, 2, 3, 4, 5, 6, 7, 8 basic families of functions. Now you're going to have to memorize these functions. They're going to be definitely quizzable and testable material, as in give and draw the 8 family parent functions. Name, example, and equation. Name, example, and equation. Now, what we're going to do here is we're going to talk about how do you turn those functions into something else. Well, I want you to write down the following. C plus a function, all right, x minus d. All right. Now, in this case, you're going to take, and you have some placeholders. C, which is vertical shift. You have A, which is amplitude. And you have D, which is horizontal shift. Now, this is a generic standard. When we get to trigonometric functions, I'm going to add another letter right in here, but for now, we don't need it. So, vertical shift, amplitude, horizontal shift. So, if I were to take a function like f of x equals, and let's say 2 plus 3 parenthesis x minus 4 squared, and we want to graph something like this. These key pieces in the right places tell us what to do with that to actually get it graphed. Now, for every single graph of this that you do, I want to see each step. So, when we're graphing these, the very first thing you're going to do is you're going to graph the parent function. Now, by parent function, we say, well, what kind of function is this? It's not y equals mx plus b. It's not an absolute value. It's not a square root. It is, in fact, a parabola. It's going to be a quadratic function because it's raised to the second power. Now, so the first thing we're going to do is we're going to draw a dotted line in, and that represents x squared. Now, if that represents x squared, everything else we do to this is going to be based on being x squared. Now, if this says vertical shift, this is going to be the number that is added or subtracted onto it, and it's just tacked onto the function. Now, it could be 2 plus all this, or it could be all this plus 2, but the key is it has to be just tacked on additionally. So we're going to take this function, we're going to move it up 2. So we just move the whole thing plus 2. Now, in this case, we have x minus 4. Well, that's the horizontal shift. What you need to understand is that this 4 would be 4 to the right. The reason it's 4 to the right is because x is built into the equation. Minus is built into the equation. So what got put in for the d? Positive 4. So we're going 4 to the right. 1, 2, 3, 4. So now we have this parabola. It's been moved up, it's been moved over, and we're ready to do something else with it. Now, the last thing, because whereas this is vertical shift, this is horizontal shift, this right here is going to be amplitude. Now, amplitude you need to think of in terms of stretching it vertically. Okay, if it has more amplitude, it's more stretched. The other way to think about it is this 3 means for every bit that I go over, instead of going up 1, I go over 1 but up 1, 2, 3. Instead of over 2 and up however many this is, it's 1, 2, 3. And so what you end up with is the same problem, but it's now much taller. Now you'll notice a parabola, when it gets taller, actually looks skinnier. Okay, so taller in essence turns into skinnier in terms of parabolas. That will be the case in cubes. That will be the case when you start talking about square roots. That'll be the case when you talk absolute value. This is a little weirder. It's a matter of how tight it is into 0. And this, of course, because it's linear, it's going to determine its slope, okay, how fast it goes up. But that's the idea. So these transformations are going to use a vertical shift, an amplitude, and a horizontal shift.